So, reason I'm doing this is because in addition to doing authoritative DNS, we host 550 of the top-level domains on our authoritative side, including ones for 130 countries, and we provide back-end infrastructure for 2 of the root name servers and so forth. So on our authoritative side, we've been the largest DNS network for almost 30 years. On the recursive side, though, we hadn't really seen a reason to do anything for a long time, and then Google started hassling the European privacy regulators, wanting a one-off exemption from GDPR so that they could keep snarfing up people's click trails through the 8.8.8.8 recursive resolver. And the regulators were saying, of course you can't have that. And then Google would come back to them and say, but this is critical internet infrastructure that can only be supported through the sale of advertising, blah, 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 right? Anyway, so regulators were coming to us and saying, well, we don't think this is necessary. We think that it should be possible to do recursive DNS without snarfing up everybody's personal data and selling it, but we can't prove it. We're just regulators, right? And so we went around to our donors, and a bunch of them were enthusiastic about having us set up a GDPR-compliant recursive resolver that wouldn't collect any data at all. So that's what we did. It's called Quad 9. It's on 9.9.9.9, courtesy of IBM. And IBM doesn't have any. That was a donation from IBM. It belongs to us now. There's no quid pro quo to IBM for that. And it's also on 2620 FEFE. So as you'll see in the talk, IPv6 is surprisingly stable and performant. So any place you have IPv6, you should use it. OK, so lessons learned and things that we think we know as a result of going through all this. Dane is going to save everybody's life. There are huge, huge problems with certificate authorities. That's just not going to fix itself. It gets worse and worse over time. We've known this for 20 years. Dane is the solution to that. The problem is that the IETF is really, really slow, so Dane basically only works on SMTP right now. We desperately need Dane on IMAP, DNS, RTP, Jabber, so forth, right? Things that right now get secured using CA certs. So there are the 3 RFCs that define it. Basically, Dane is self-signed certs slammed into DNSSEC signed zones, right? So if you want to go to a resource that you're finding through the DNS, you also get the appropriate cert for that thing, and it's all signed all the way down. So privacy. If you want your DNS to be private, you really, really want to run your own caching resolver. So if you're on a laptop, you can run a caching resolver on your laptop. It'll give you a little bit of enhanced privacy in that at least you'll have an answer locally for things that you go to often. It'll give you some more security in that you'll be a little less vulnerable to man-in-the-middle attacks. You'll be able to do your own, sorry, jet lagged, QNAME minimization, where when you send a query out to an authoritative server, you only send the portion of the query that that server can answer. You don't just gratuitously send your entire query to somebody who isn't going to be able to answer that query and is only going to be able to give you a referral, right? So all due respect to the folks in the room who make their living by snarfing up DNS queries from in front of other people's name servers and selling the data, you can prevent that portion of the leakage of your data and other people's monetization of it by, like, for instance, if you're going to the root, you only query for the TLD that you need for the next step. And then when you go to the TLD, you only query for the second level you need for the next step. All right, there are a couple of online tutorials there. Well, this is a tutorial about how to use Stubby, which is the most common encrypting interface for local caching resolver. And this is a GitHub repository of a sort of pre-built Docker installation of one. eDNS extended client subnet. This is one of the real evils that we run into. And it's really prevalent now. It's, if you start looking at queries going across the internet, the vast majority of them are doing extended client subnet now. So this is where you send a query to a recursive resolver, and the recursive resolver, instead of just doing the queries it needs to do to get you an answer, it gratuitously sends your IP address or a subnet that encloses your IP address onto authoritative servers. So now, not only is your query going to places it doesn't need to go as a full query, it's also got your IP address attached to it. So the theory here, the way this gets marketed as being necessary, is CDN operators say, oh, well, we couldn't possibly give you optimized performance if you didn't tell us your IP address. Worked fine before this, but of course they don't make as much money if they can't sell your IP address to advertisers. So the problem here is any recursive resolver you use, you're going to have to trust not to do this. A way of testing this, of course, is do a query through a recursive resolver to something you're authoritative for, and PCAP the query coming in from the recursive resolver and see whether it's passing IP addresses, right? You should also know that there are people who are, there are CDNs out there that are starting to penalize people who don't give them their IP address, right? So there are people who are starting to try and normalize this in the sense of not answering queries that don't come with an IP address or giving them purposely degraded performance. So this is a political issue and a big one, and it's pretty invisible to most people. Because what you get is commercial recursive resolver operators telling users, oh, we've got to do that, it's for your benefit, and you know, if we didn't, you would be the loser here, right? And so users wind up thinking this is a good thing rather than realizing just how bad it is. Fingerprinting. The state of the art has gotten to the point where you can fingerprint OS and browser just from the DNS queries that they do loading a page, right? So the same page, web pages getting loaded by different browser OS combinations are going to do things in different orders, different ancillary queries, that kind of thing. So fingerprinting is possible just from the DNS stream. Okay, so you've got DNS over TLS and DNS over HTTPS. One of the big things that we were doing with Quad 9 was proving that you could do this stuff encrypted. Prior to this, there was only a protocol called DNS crypt that was proprietary and just worked with OpenDNS. And it's okay. It's not perfect. No protocol is perfect, but it's not bad. The problem is that it's caught up in politics, and is, because of the politics, it will never be a standard, right? It is proprietary. And so the world has left it behind. There aren't new DNS crypt installations going in, and everything else that's growing is not DNS crypt. So that leaves DNS over TLS, which is sort of the normal regular standard, and DNS over HTTPS, which is the Trojan horse fake standard for snarfing up your data by CDNs, right? So the CDNs are pushing DNS over HTTPS, which again allows them to do fingerprinting and all kinds of stuff. The HTTPS libraries leak a tremendous amount of information that's completely unnecessary to a DNS transaction. DNS over TLS doesn't send anything extra that's not needed. So what the DNS over HTTPS folks are trying to do is basically lock in your DNS as well as a lot of your web browsing, and again give you this sort of trade-off. Like if you use their DNS, they can see what you've looked up, and they can start to push web pages at you before your browser asks for them, and they can start to push additional things to you in advance of you having done lookups, right? It's a good way to use up bandwidth. It makes them look very performant relative to their competitor, but there are always going to be competing CDNs out there, right? And you're not going to be choosing your DNS recursive resolver based on what CDN the web page you're next going to load is hosted on, because you just don't know, and that'd be a huge hassle. So be very, very skeptical of DNS over HTTPS, right? If you see reputable people who don't have any money coming to them from a CDN operator or somebody who monetizes personal information, then sure, listen to that argument, but otherwise be skeptical. Performance is actually fairly simple. We've got this huge network for doing authoritative. We're in 200 data centers around the world. And so we're very close to users, and we thought that would make a huge difference in performance with the recursive DNS. And it turns out it doesn't really. The difference is not that huge. So, all of the big Anycast recursive DNS networks give essentially roughly equivalent performance, right? There are places where Cloudflare is a little faster than we are. There are places where we're a little faster than OpenDNS, but in real world terms, somebody's DNS query getting answered in, 15 milliseconds instead of 10 or 10 instead of 5, it really doesn't matter, right? Even when stuff is sort of cumulative delay on a bunch of lookups on a page or something, the user is starting to read the page. Well, DNS lookups and ads are loading and junk further on down. It's not that big a deal. The thing that makes the huge difference is having caching, having large caching, having caching that lots of other users are using. So what this says to me is you always want to have a local cache at the edge of your own network. If you're in an enterprise or something, probably you want that kind of hierarchical. You want one of those at every site, and then have those either go straight to recursive externally or in a hierarchy to sort of a big one for your enterprise as a whole. To the degree that you can get a bunch of users sharing a cache, the first person to get an answer is going to have gotten it on behalf of a whole lot of other people. The other thing, there are a whole lot of, again, sort of CDNs and advertisers and that whole crowd who try to do cache busting, and they try to do, TTL 0 on every response so that they'll see every single query and know exactly who's loading their ad and so forth, right? If you control your own cache, you can control a lot of that, right? If you can control your own cache, you can artificially say, to hell with this TTL 0, we're doing a TTL of a day on everything, right? At which point, you've got a day between each time you leak information. And also, you're not having to go out to get it over and over and over and make people wait each time. So again, your own cache that you can tune, and you can control what's leaking out, and you can see how much is leaking out. Really good thing. Security. There are a lot of folks who say having centralized recursive resolvers is a problem in and of itself. And I wouldn't say that that's the case. And there's sort of, this is a trade-off. If you have a centralized resolver, it means that when there's a problem, it's going to get solved quickly. But on the other hand, a lot of people will have been affected by that problem before it gets solved. So that's a trade-off. But the second thing, we and OpenDNS both do malware filtering, right? So you can, if you're sending a query to Quad 9, optionally have it block any response that would have taken you to like a drive-by site or a phishing link or, whatever. So we get feeds from 30 different threat intel providers that we blend together, and we do sort of reputational scoring on those because they're not all great. Many of them have a lot of false positives, and so we wind up with a sort of a whitelist in addition to catch false positives. There's a whole lot of tuning that happens there. The OpenDNS one is the Cisco Talos one, which is also used by Quad 9. So it also works well. But that's just like that whole hassle is manual, and if you had to pay for it, it'd be very expensive, and it's not something you really want to be doing if you can avoid it. But again, if you use that as sort of an external service, you've got your own caching, you're not sending anything you don't need to out to the recursive resolver, and you pick a recursive resolver that has privacy policies and transparency and so forth that you're happy with, then, that seems to me like a pretty clear win. Okay, authenticity. Knowing what the name server you're talking to is important so that you're not getting man-in-the-middled. Dane, of course, is the gold standard for that, where you can authenticate the server that you're talking to as you're talking to it. DNS over TLS is a good first step. DNSCrypt has something in there for doing that. In theory, key pinning would work if it were supported in clients, which it isn't, to the best of my knowledge, although there may be some way of hacking that in. And we've got this sort of all or nothing thing that the DNS over HTTP folks are trying to do. So between DNS over HTTP and extended client subnet, we're getting, like the politics are starting getting to the point where your ability to reach some websites may be gated upon your willingness to give personal information. And again, I feel like the sooner the better that politically we can steer away from that and make that obviously unacceptable, better way of going. Reliability. All of these big Anycast ones have multiple IP addresses. Ideally, what you want is multiple v4 and multiple v6. You have to hope that they know what they're doing with Anycast and are not just routing all those addresses back to the same clusters. Got different talks on that. But you can also just use two different ones, right? So the problem here is you see a lot of people on, like in forums online saying, oh yeah, we did Quad 9 and Cloudflare. The problem here is now the client is sitting there sending queries, and they don't know on a per query basis which one went to which provider, right? I mean, unless they're PCAPing their own traffic, they don't know which of those name servers got used for any given query, yet those have radically different privacy policies, right? So you want to make sure that you're okay with the privacy policies of the ones that you're using and that they're roughly similar, right? If you're going to use multiple providers. No problem with using multiple providers. It's probably a good idea. But just be aware that different providers have radically different policies, and you want to be aware of what those are. And, exercise a little bit of judgment, right? And don't just take things at face value. If somebody says something on Twitter about what their policy is, you want to probably actually go read the fine print, right? The other thing, like I said before, IPv6 transport is often more lightly loaded, and where IPv4 and v6 are getting served by different resources, the v6 one is often over-provisioned relative to load. So, your mileage may vary, but what we see is people getting much better performance on the v6 side than the v4 side. So, Like, don't just pop in the v4 address and call it done. Put in the v6 address, put it in as higher priority, and see where you get. And then lessons learned. As an organization, if you're operating servers, either authoritative or recursive or caching, having some visibility, collecting some statistics, keeping a rotating PCAP buffer, whatever, so that you can go back and see what's going on is really, really useful. On the authoritative side, on the recursive side, we're not doing any of that, and that's like an acknowledged weakness, right? If we're not capturing any data, it also means that it's really hard. We can't really go back in time and see what happened when something happens, right? On the authoritative side, we're doing that for hundreds of different organizations, and they want us collecting data so that they can tell what's going on when there are problems. So on the authoritative side, we're following the privacy policies that are dictated by the people we're serving. And so by and large, what we're doing for many of them is keeping a 1-week rotating PCAP buffer of the traffic into their servers. And that's really saved our asses a lot of times. So if you need to boil down statistics, if you're a service provider, boiling down IP addresses at the BGP advertised level is probably good enough. If once you're out of the, we've still got a PCAP with an actual IP address in it, if you're just trying to keep statistics. But for any enterprise, you can keep the whole thing. Disk is cheap. Trying to collect everything, like PCAPs for a while is great, but then once you start trying to boil things down into a database, the numbers get really big really quick. And so you got to figure out in advance what you're going to capture, because otherwise your indexing and so forth will just kill you. Time series databases are good. Relational databases simply don't work for this stuff, right? You can't add millions of records per second to a relational database and have it be usable, right? And that's not going to get better faster than traffic levels increase, right? It's a problem that's sort of been getting worse and worse over time. In general, there aren't a lot of good pre-built tools for this stuff unless you're very small. There's something called DSC that for sort of small enterprise is great. It doesn't scale, but if you're small and not going to grow a lot, it gives a lot of nice visualization and logging and ability to do queries and so forth. So one of the really frustrating things is a lot of people will be operating something small and they'll get really used to using DSC and all the sort of neat knobs and tools it gives them. And then they'll get into a large situation and suddenly feel like they're blind. There isn't a lot to be done about that because DSC depends upon having a heavily indexed relational database of stuff that it can lunge away at. Our big limitation is we're not a software development shop, right? And so we're dependent on what software developers do in terms of implementation, and they often don't have any sense of operational requirements or what's needed for doing security and figuring out what's going on in a security context. So we have a lot of kind of odd conversations with software developers where they can't understand why we'd want to be able to keep some statistic or go back and look at what's going on, whatever. And obviously, there's a lot of performance that gets tied up in that, right? They want to be able to run fast, and that often means letting a lot of stuff slide by. Looking at CPU cycles on our gear out there, 80% of the CPU cycles are dedicated to logging, 20% to actually serving packets. Again, that's on the authoritative side because people want to know what's going on. They want to be able to backtrack problems. And IPv6 for a long time was the thing that software developers just couldn't wrap their heads around supporting. Now it's TCP. In the DNS there are a lot of software developers who are still thinking in a very stateless mindset, right? So even their TCP implementation doesn't really use TCP efficiently. It's not looking at long-lived flows. It's not prioritizing top talkers. There are a zillion things that can be done to improve performance of TCP. Essentially, at this point, DNS, there's no question at this point that DNS is going to be over TCP, right? DNS over TCP is already, if not predominant, it's the most important traffic for name servers that matter. Okay, so between big resolvers and big authoritative, it's all TCP. And shortly, it'll all be TCP encrypted, right? So everybody's got to be paying attention to that and realizing what that means, right? So if you've got like debugging tools that depend on TCP being unencrypted UDP, those can't be applied to DNS traffic that matters anymore. So, all right, that was all I had. It is 4:29. 1 minute for questions. Yes.
Quick shout out to DNS Path, which is a logging format built into some of the popular resolvers. If you are a server operator and can't rely on capturing traffic,
Yep.
DNS Path will create structured records of client queries and responses at the DNS level in a protocol independent way that doesn't require you to understand your TLS.
Right, which also means that different analytic tools can look at the same data stream, which is great. And yes, we've been pushing software developers to standardize on it. Yes. Yeah, I think you're right. I think this is a fairly new issue, and it's very low visibility right now. And also, the CDN operators or the content networking folks are very used to being the good guys in the net neutrality fight. And this is an instance of them behaving abusively. So, yeah, I think I think that might even out the net neutrality fight a little bit as well. So, yeah. One more question before I go. No? Okay, I'm off. See y'all later.